Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving worded problems using simultaneous equations. So when we're using simultaneous equations, the magic number's 2. You form two equations with two variables and you get that from two bits of information. All we're doing is finding two equations and then solving them using either graphical, substitution, or elimination method, whichever you choose. So let's look at this question. 2 drinks and 3 sandwiches cost $21. 5 drinks, 2 sandwiches cost $25. We need to calculate the cost of each item. We're finding two things here, the cost of a drink and the cost of a sandwich. So for worded problems, our first step's to define variable. So we're going to let x equal one of the things we're trying to find and y the other thing we're trying to find. So we'll let x be the cost of drink, y the cost of a sandwich. So this first bit of information tells us 2 drinks, 3 sandwiches cost $21. We need to turn that into an equation. We're going to rewrite that information using only mathematical symbols. So it says 2 drinks plus 3 sandwiches gives us $21. It also, the second bit of information says 5 drinks plus 2 sandwiches gives $25. Now that we've got our two equations, we just solve like we've been doing the last few lessons. It doesn't matter which method we use, whether it's graphical, substitution, or elimination. Of course, we just want to pick the easiest. Elimination would be the easiest here. So because neither x nor y has the same coefficient in both equations, I'm going to multiply the equations. I'm going to multiply the top one by 5 and the bottom one by 2. And that's because if I multiply the top one by 5, I get 10x plus 15y is 105. Remember, you have to multiply everything by 5. And for the bottom, I get 5x times 2, 2y times 2, and 25 times 2. This has actually helped me because now I have a situation in which the x has the same coefficient in both equations. So because it's a positive 10 in both equations, I can subtract. Same sign means you subtract in order to eliminate the variables. So here I'm eliminating the x's. 10x minus 10x is 0. 15y minus 4y is 11y. 105 minus 50 is 55. Dividing each side by 11 gives us 5. The cost of a sandwich is therefore $5. Okay, what about the cost of a drink? Well, we can substitute y equals 5 into any of these four equations. It doesn't matter. I'll just substitute it here. So substituting this all the way into that equation there, I get 2x plus 3 times 5, so 3 times 5 is 15 equals 21. Of course, I get 2x equals 6, x equals 3. X was the cost of a drink. So a drink must cost $3, a sandwich $5. All right, let's now look at a slightly harder worded problem. So a school contains 800 students, 70% of all boys and 50% of all girls play sport. 486 students play sport. We need to work out how many boys and how many girls attend the school. So here there are two unknown quantities. How many boys and how many girls attend the school. So two unknown quantities, we've got two bits of information, and we're going to form two equations. So let's start by defining two variables. So what we're going to do is let x be one of the things we're trying to find. So I'll just let x be the number of boys who attend the school, and then we'll let y be the other thing I'm trying to find. So y will be the number of girls attending the school. All right, we need to form two equations from two bits of information. First says a school contains 800 students. So the number of boys plus the number of girls is 800. The next bit says that 70% of all boys, so 0.7 times x is 70% of x, plus 50% or half of all girls play sport. That adds up to 486 students. We now have two equations with two variables. We solve them simultaneously. You can use graphical substitution or elimination. I think once again, elimination is going to be easier here. So what I'm going to do to make x's have the same coefficient in both equations, I'm going to multiply this equation here by 0.7. So that will mean the first equation becomes 0.7 times x, 0.7 times y, and 800 times 0.7. Now I'm going to focus on these two equations because x has the same coefficient in both equations. So again, same sign for these coefficients means I subtract. So 0.7x minus 0.7x is just 0. So 0.7y minus 0.5y is 0.2y. It doesn't matter if I do top minus bottom or bottom minus top. So I've just gone bottom minus top. 0.7x minus 0.7x, 0.7y minus 0.5y. So of course then I have to do 560 minus 486, which is of course 74. So now I need to get y by itself. I undo timesing by 0.2 by dividing by 0.2. So 74 divided 0.2 turns out to be 370. There are 370 girls attending the school. And so if we substitute here, x plus 370 is 800. X must be 430. There must be 430 boys attending the school and 370 girls attending the school. Just note 70% of 430 is 301. Half of this is 185. 301 plus 185 gives 486 students playing sport. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.